Do not sign a battery energy storage system proposal until you understand exactly how a vendor is modeling the payback, because the utility incentive payments attached to these systems are consistently one of the most misread numbers in the pro forma. I am Daniel Burke, and this is Energy Answers brought to you by Tactical Energy Group. Today, we're decoding battery energy storage systems, BESS, specifically for peak shaving and resilience at commercial and industrial facilities. If you're evaluating a BESS project right now, or a vendor has put one in front of you, here is what you need to know before you say yes or no. So here's the short version. A battery energy storage system is a large on-site battery that charges during low cost or low demand periods and discharges during your peak demand windows to reduce the demand charges on your electric bill. Now, that same battery also keeps critical loads running during grid outage. The question for your operation is whether the economics, capital cost, demand charge savings, utility program revenue, and upfront rebates actually stack up to a payback that holds up under scrutiny. If you caught episode 11 on peak shaving strategies, you already know why cutting demand charges matters so much in today's market. So today, we're getting into the hardware that actually makes peak shaving happen automatically. And if you want to understand how a battery energy storage system fits into the broader picture of monetizing distributed energy resources, episode 8 on FERC Order 2222 is worth your time. A battery energy storage system is one of the strongest assets you can bring to that environment. The facility types where this decision comes up most often are factories, hospitals, logistics hubs, large commercial buildings, and schools. If demand charges are running 30% or more of your electric bill, or your demand charge rate is above, let's say, $15 per kilowatt month, and your load has identifiable, predictable peaks, that is the profile where a battery energy storage system peak shaving case is worth a serious look. So, what does a BESS actually do? At its core, a BESS charges when your facility's demand is low, often overnight or during off peak hours, and discharges during the window when your demand would otherwise peak. The result is a flattened demand profile at the utility meter, which directly reduces the demand charges your utility bills each month. The battery is doing the same thing a disciplined load curtailment program would actually do, except it does it automatically without interrupting production. The second value driver is resilience. When the grid goes down, the battery transitions to backup mode and it keeps your critical loads energized. That is an operational continuity value. Reduced downtime exposure, reduced lost production risk, and it is separate from the demand charge savings calculation. Both belong in your financial model, but they need to be measured separately. Now, on top of those two primary value drivers, there is a third layer some utilities offer: performance payments for discharging your battery back to the grid during utility called peak events. Now, I want to use NYSEG's Energy Storage Solutions program in New York as an illustrative example here, but I do need to be upfront about how we're looking at it. The NYSEG program I'm about to describe is technically scoped to residential and small business customers. I'm using it as an illustrative example of how utility storage program mechanics work, because larger commercial and industrial facilities typically evaluate parallel commercial programs with similar structural logic but different rates and terms. Verify your specific eligibility before modeling any of these numbers for your specific facility and project. Now, with that said, here's how the mechanics work. The NYSEG program is ratepayer funded and overseen by the New York Public Service Commission. Performance is measured per event. An event is a defined period when the utility calls on enrolled batteries to discharge. Your event performance is the average of your hourly discharge across the event window. If your battery discharges 3 kW in hour 1, 2 kW in hour 2 and 4 kW in hour 3, your event performance is 3 kilowatts. Your seasonal compensation is then that event performance averaged across all events in the summer, multiplied by $50 per kW paid once per year. Using that example, 3 kW times 50 equals $150 for the season. Now, again, those are the residential and small business program rates in NYSEG. A commercial program in your environment at a larger scale will have different terms, but the calculation logic, average delivered kW across events multiplied by a rate paid seasonally, is structurally similar to what you will encounter elsewhere and certainly wherever you are. That payment structure is the real thing. The revenue it generates is also modest relative to the capital cost of a battery energy storage system. Utility program revenue is a supplement, though. It is not the primary driver of your payback, and any pro forma that features it prominently as a payback mechanism deserves a real, hard second look. Now, on the capital side, there are upfront installation rebate programs that reduce your initial cost. In New York's NYSERDA residential and small commercial program, it offers up to $200 per kilowatt hour of installed battery capacity for standard customers and up to $400 per kilowatt hour for customers in designated disadvantaged communities. Those figures apply to the same residential and small business tier I flagged on the performance payment side. NYSERDA also runs a separate retail storage incentive for larger C&I projects with a different block-based structure. Check the current NYSERDA commercial and industrial block pricing for your specific project rather than assuming the $200 or $400 per kilowatt hour figures apply to your specific facility. And again, we're just using one of the New York programs for our illustrative example in this particular episode. Regardless of which incentive tier applies to you, upfront capital rebates belong at the front of your model as a cost reduction, not mixed in with the operational revenue we expect to generate. One practical procurement point that routinely gets missed in some utility storage programs, including the NYSEG example, enrollment is gated through the battery manufacturer's app or an approved hardware list. More broadly, most commercial and industrial programs restrict eligible hardware through certified environment lists or aggregator platforms. Either way, the battery you specify at design determines which programs you can access later. That is a procurement decision, not just a technology kind of decision, and it needs to be resolved before you finalize your hardware specifications. Finally, because these programs are ratepayer funded and PSC overseen, the payment rates, event frequency, and program terms can be modified by regulatory action. Any 10-year financial model that treats utility program revenue as a fixed line item is carrying unmodeled regulatory risk of materially lower payments or program restructuring before that model horizon closes. So here's my take. The battery energy storage system business case is real for the right facility, specifically one with high demand charges, meaningful resilience exposure, and the capital appetite to absorb an asset that pays back over years instead of months. The problem I see consistently is vendors front loading the pro forma with utility incentive revenue and burying the assumptions that make it fragile. For most commercial and industrial facilities, demand charge reduction is the largest single value driver, but the ratio depends on your specific demand charge rate, your load profile, and installed battery energy storage system capital cost. The point is not that incentives never matter. It's that if the demand charge math doesn't work on its own, incentives rarely rescue the project. Model the project on the primary drivers. If it works on those, the incentive stack makes a lot of sense. If it only works because of the incentives, walk away from that project. That's my recommendation. Now, obviously, I don't run your facility. That's your job. My job is to bring you definitive answers to the most pressing energy questions facing commercial and industrial operators like you. Bottom line on battery energy storage systems for commercial and industrial peak shaving and resilience. A battery energy storage system is a capital investment that earns its payback primarily through demand charge reduction and backup power value. Utility performance payments are real, but supplemental revenue stream, and they carry regulatory risk that your model needs to account for upfront. So here are the questions worth taking to your team. What percentage of your electric bill is demand charges? And has anyone run a load profile analysis to determine whether a BESS would materially reduce that number given your actual load profile? If a utility storage program is included in the vendor's pro forma, has anyone verified that the specific battery hardware being proposed is actually eligible for that program's enrollment workflow, and that the program cited covers your customer class, not just residential or small business or commercial or C&I accounts? You need to know what it actually covers and if you're included in that group. Now, what is the assumed payment rate and event frequency in the pro forma? And has anyone stress tested what happens to the payback if the utility modifies program terms mid contract? Is the resilience value in the model based on actual documented downtime cost for your facility, or is it a generic number the vendor inserted to compress the payback period? That is a habit, a nasty habit you have to watch out for when it comes to energy solutions vendors. Now, look, if today's episode got you thinking about a battery energy storage system project you have in the works or one a vendor has put in front of you, I want to help. The team at Tactical Energy Group created the Energy Decision Blueprint for exactly this situation. If you're an Indiana based commercial or industrial operation spending 5 figures or more on electricity each month, and you're evaluating a project like this, here is what we do. We get on a call with you, understand your situation, and figure out if there's a way we can actually be helpful. If we can, we'll pull together your bills and interval data, crunch the numbers, and give you our full take. Whether the payback is real, whether the vendor modeled your rate correctly, and what you may have not considered. You get a full energy project evaluation with no obligation whatsoever to anything else. This process is free for qualified Indiana operators. Click the link in the description below or go to tacticalenergygroup.com and look for Energy Decision Blueprint. Thank you for listening to Energy Answers, brought to you by Tactical Energy Group. If this helped, send it to another operator you know who's dealing with the same headache, and visit tacticalenergygroup.com to get more practical tools for your facilities.